In this video, we're going to be starting proof, and I want to introduce you to logical consequence, okay? So, if you think about solving an equation, so let's say we've got an equation like 3x plus 5 is equal to 7, then usually what I may do sometimes and what you may do is you draw an arrow, okay, meaning I'm going from that line to this next line, where I would take 5 from both sides, so I'd get 3x is 2, and then I would draw another arrow, meaning, right, that means that x is equal to 2/3. Okay, so essentially what I'm saying is that this is an arrow that we generally use anyway, and what you may not be aware of is that it has a mathematical meaning. Okay, it's not just an arrow that we use to just go from one line to the next. There is an idea behind it. So in mathematics, there are actually different types of arrows that can be used. So you'll notice that I'm not using this arrow, for example, because this arrow means something else. This means something tending towards something else. So that is used in a different context. I'm using specifically this type of arrow. So, what does it mean? Well, this arrow is an implication arrow, okay? So what I mean is that A, arrow B, means that A implies B, okay? So, in other words, if A is true, then B is true. That is what this symbol means. So in other words, if 3x plus 5 equals 7 is true, then that must mean that 3x is equal to 2. And if 3x is equal to 2, that must mean that x is equal to 2/3. Okay? So as another example, if we had an A and a B like this, so we've got two statements. P is a prime number greater than 2, so P would be something like 3 or 5 or 7 or 11 or 13. That must mean that P will always be an odd number. So all those numbers that I read out, they are odd numbers. So if P is a prime number greater than 2, then that implies that P is an odd number. Now, what's interesting is then to think, right, well, is the converse true? Now, what I mean by converse is if I change the direction of the arrow, so if I now draw the arrow going this way, does this still make sense? So, if P is an odd number, does that then mean that P is a prime number greater than 2? So P is an odd number. It could be 3, 5, 7, 9. So if P is 9, for example, does that mean P is a prime number greater than 2? Well, 9 isn't a prime number. So that must mean that the converse doesn't work. The converse is not true. So that you could effectively put an arrow through it, meaning this does not imply this. So ultimately the arrow should point this way, okay? And that is logical consequence, when one thing implies another.